Welcome. We're doing our project on biofuels, concentrating in algae oil. We're Team M, and my name is Crystal Guerrero. Fossil fuels versus biofuels. Fossil fuels are non-renewable, and they contribute many toxins into the air by releasing carbon dioxide, while biofuels actually consume carbon dioxide and are renewable. There are three different types of biofuel. You have the first generation, which can use animal fat, sugars, different types of oil like seed and corn. Then you have our second generation, which uses vegetable oil, wood chips, coal, things that cannot be consumed by humans. And finally, you have algae, the emerging generation. Algae is a renewable source, and it can reach its full growth in just a matter of weeks. And algae actually consumes carbon dioxide while it grows. There are three different types of algae methods. You first have algae growth. You have photobioreactor, closed pond, and open pond. Then to extract the oils, you have to use the mechanical press or the chemical method. And finally, to extract the oil to create biofuel, you use the transesterification method. Now, Maria is going to talk about bioreactor growth. Thank you.
Hello, my name is Maria Aramayo, and I'm going to introduce the first way of algae growth. It's called photobioreactor, and this is a simple graph of how it is achieved. Advantages and disadvantages. It has a good control of circumstances such as temperature and gas transfer. However, it's expensive and it needs to be cool. It needs cold water and air conditioner, and it doesn't work in warm environments. The second one is open pond growth. This is a real life open pond, and this is a graph of how it works. The advantages and disadvantages of open pond. It's the least invasive. It's a simple system. It's not that expensive. But however, the disadvantages is that it requires a lot of water and it has bacterial contamination. The other one is called closed pond. And yeah, it's closed and it doesn't let bacterial contaminants go. However, it's still not as protective as the other one, like biofilm photobioreactor. That's why we're going to have a biofilm photobioreactor as our design alternative chosen due to its good advantages. Thank you. The next one is going to be Evelyn. She's going to talk about the system components.
Hello, my name is Evelyn, and I'm going to continue talking about our chosen design alternative, the biofilm photobioreactor, using algae. On the right is a schematic of what it looks like roughly. It consists of a biofilm growth surface, which is a concrete slab, and it is tilted at a 0.2 degree with respect to the horizontal, so as to allow the nutrients to flow at an angle over the length of the algae. It has a nutrient medium recirculation system so that those nutrients can recirculate through the system over and over again through the span of a few days to allow the algae to grow. It also has an illuminator system that consists of fluorescent lamps because this system can be kept indoors and the fluorescent lamps replace the sunlight that it needs for the algae to grow. The pH of the concrete slab is reduced to make it ideal for the algae to grow, and the total liquid volume of this system is 600 milliliters, which is one of the reasons why we decided to choose this system. It requires less energy and less liquid volume for the algae to grow as compared to the other systems that were briefly discussed previously. Our procedure. The algae culture, is introduced onto the carbonated concrete surface, and nutrients are not circulated for 5 days. This is done so that the algae is allowed to adhere to the concrete slab. Continuous illumination is provided to the biofilm photobioreactor under operation for 35 full days. Within these 35 days, samples are taken from the biofilm and tested to ensure that the samples are not contaminated. The cultivation process. After the 35 days required for the biofilm to grow, you will be able to see a real-life picture of what it looks like here on the bottom left. This is the algae on it before extraction or cultivation, and on the right is the concrete slab after the algae has been extracted or cultivated. The biomass on the concrete slab is removed using a squeegee. The squeegee method was the preferred method because it was shown that the biomass, was able to be removed successfully with no contamination. After the biomass is harvested, it is dried either through centrifugation or another method, and then the algal oil is extracted by one of the following methods. We're going to talk about the mechanical press method. There are 3 types. There's a screw press, an expeller, and a piston. On the right-hand side is an example of a screw press, and you can see the oil that has been extracted already. At the bottom picture, it's the yellow liquid that's there. The algal oil is extracted using an oil press. This is the mechanical method. It extracts between 70 and 75% of the oil from the algae, and then the solvents included in the oil the solvents are used to separate sugar that's in the oil from the oil, because the end result has to be the oil only. The solvents then evaporate, and the only thing that is left behind is the oil, which can then be used directly in diesel engines or refined further. Next is chemical methods. You can use a combined approach between chemical methods and a mechanical method to extract the oil from the algae biomass. This would be an oil press in conjunction with a hexane solvent combination. This will allow up to 95% of the oil that's contained in the algae biomass to be extracted. You can also use the supercritical fluids method. With this method, carbon dioxide acts as a supercritical fluid to extract the oil from the algae, and you can achieve up to 100% of oil extraction from the algal biomass. There's also a soxhlet extraction method, which is also through the use of chemicals. Now, this alternative is favorable because it is inexpensive, so it reduces costs of production and extraction. However, there are precautions, that need to be taken as when you're using any chemical. There's explosive hazards. It's also hazardous to your skin and your body, so adequate protection needs to be used. Next, Michelle will come up and speak about the transesterification process. Thank you very much.
I'm Michelle. I'm going to further discuss transesterification. The goal is to convert the algal oil into biofuel. This works by using a catalyst, sodium hydroxide, alcohol, methanol, and the oil, and it turns into biodiesel fuel and a mixture of glycerol. Next step is to remove the glycerol, which is done by allowing the biofuel to go to the top and the glycerol to remain at the bottom. These are some more specific results over the 35-day cultivation period. Algal biofilm thickness is 278 microliters, very thin. It yields about 25 grams per meter squared. The light to energy efficiency is 2 to 3%. The direct harvest yielded concentration is 96.4 kilograms per meter cubed, and the energy used for the nutrient recovery is 32 kilojoules. The evaporative loss is 1 liter per meter squared per day, and the productivity is 0.7 grams per meter squared. The parameters for the energy used to create oil are listed here. You can see all different kinds of necessary parameters. Here's the table 2, which is 1618 liters of water per kilogram of biomass produced, what it requires. If there are any further questions, please contact the address listed here. And thank you for your time.